In this video, I'm going to go through a Leaving Cert past paper question on organic chemistry. It's 2016, question 8. It has to do with the alkenes and their chemistry. To start with, we're asked to name compound A and polymer B. Okay, so compound A here has been formed by adding water to ethene. So I'll go through a bit of detail here. Ethene has a structural formula like this, and if I add water to it, I will need an acid catalyst to do that. The product I will form is ethanol. Okay, because that's a hydration reaction or an addition reaction. Polymer B then, here, can also be formed from ethene. Okay, so this is going to be the case when ethene, the monomer, and we can say we've got N of those, and what happens is when they add on using suitable catalysts to each other, you end up forming these really long chains, and surrounding the carbon atoms there in the chains are all hydrogen atoms, and so the polymer is polyethene. So the answer will be polyethene, and the answer to A is just ethanol. Identify substance X using the conversion of A to ethene. So here we have the reverse reaction of hydration or addition of water. It's a dehydration reaction, and the conditions used to dehydrate ethanol and go back to ethene is heat, and aluminium oxide is the catalyst used. So X equals aluminium oxide. So I'll just start by B. Which is Al2O3. What organic reaction is involved in this conversion? That is an elimination reaction, because we are eliminating water from the molecule. How does the geometry around the carbon atoms change in this conversion? We are going from tetrahedral, where all of the atoms around the carbon atom, the 4 atoms, are evenly spaced apart, to planar. Trigonal planar, but planar. Because those atoms around the double bond geometry here at the top, okay, are evenly spaced out around the carbons, but it's in 2 dimensions there. Just going up and across, it's not going out and back. Okay, whereas with the other molecule, it's tetrahedral. We're using all 3 dimensions there. So just looking at C down here, we know that I'm going from ethane to chloroethane. That's a substitution reaction, a free radical substitution. Describe in detail the mechanism for the reaction using UV light. Okay, so I'm going to go through that now. So the reaction that we're talking about is the reaction of ethane, which is C2H6, and chlorine in the presence of UV light to form chloroethane. And it's a substitution reaction because we're substituting one of the chlorines there for one of the hydrogens in here. So we have an initiation step to begin with, and this is where the UV light homolytically breaks apart the chlorine molecule. So Cl2 just breaks into 2 chlorine radicals, and I'm just going to draw my radical with a dot. So just going to describe on the side here what happens. You've got a chlorine molecule And I'm just going to draw the dot and cross diagram for each of the chlorine atoms when they're covalently bonded. Okay, and all that happens, the UV light breaks apart the shared pair, and each of the electrons just goes straight back onto the chlorine atoms. So you're left with two chlorine atoms in their original state. Of course, these are not very stable, that's why chlorine exists as a diatomic molecule. Okay, so you form two of those. Now, free radicals themselves are quite reactive, so what they can do is they can react with other molecules, and in many ways its chemistry is hard to control. But that's just showing you what is happening in each step. The UV light breaks apart the shared electron pair, and you form two chlorine atoms, and we're going to call them free radicals. So I'm just going to put that to the side. So the next step is called propagation, and that's where our free radical is going to go and do something now. So we formed a chlorine free radical here, two of them in fact, and the first propagation step is where one of the free radicals will react with the other reactant in the chemical equation. So that was our ethane, C2H6. And all it does is, and I've described this in detail on the website, all it does is the free radical will abstract hydrogen atom, and you will get another homolytic breaking of the hydrogen atom and its carbon atom's covalent bond, where you get even breaking of the electrons, and so you form a carbon radical. So they react, and it just takes a hydrogen atom away, so you form HCl with a radical on the carbon. So just to explain that in a little bit more detail here, the chlorine radical sees the ethane and what happens is that electron and the hydrogen electron come together and form a shared pair of electrons. So we form hydrogen chloride, the molecule, and then this electron gets broken off and forms onto the ethane. You're left with HCl and this radical with there. Now we formed a different radical, and the HCl is a molecule which won't react again here, but this other radical that you formed, as it's a radical, you've got a carbon with a single electron on it, so it's quite reactive. That will go and react with something else. So that's what's going to happen next. So there's a second propagation step whereby that radical that you made, C2H5, and I'm just drawing the radical on a carbon because that's where it actually is, reacts with the other reactant, which is chlorine molecules. Okay, and as that reacts, we form this radical just forms a chemical bond with one of the chlorines, and you form C2H5Cl, which is our desired product, and we reform our chlorine radical there, our reactive species. So again, just to show you how that happens, you've got C H C H with a radical, and you've got chlorine, and what's going to happen here is that and that are going to, so a single-headed arrow I should have said at the start, that shows the movement of one electron. So what you have here is you have this product, which is the one you want, and you have reformed a chlorine radical. Okay, so we've formed the desired product here. So normally, once you form the desired product in the mechanism, you're kind of finished. But because this is radical chemistry, there's a lot of stuff that's still there that needs to be killed off, essentially. So we have these termination steps, which are basically steps that allow us to finish the reaction by not having any more radicals. in the termination steps, all that's going to happen is our free radicals are going to react with themselves and you're going to be left with neutral molecules. So the first one will be our chlorine, you could say. Chlorine radical could react with a chlorine radical. In the reverse of our initiation step to form chlorine molecule, we could have an ethyl radical and a chlorine radical reacting to form the desired product there. And lastly, you could actually have two ethyl radicals coming together. You've got an ethyl radical reacting with another ethyl radical. And what happens here is you do, when these two radicals combine, you get C4H10, which is butane. So this is our mechanism. All you need to remember are the steps in blue there. So it's important to try and remember them all because that's the best way of getting all the marks in the exam. So we'll just look at the next question now. Explain the presence of a little tetraethyl lead on this conversion. Okay, so tetraethyl lead what that does is that speeds up the reaction as it provides readily available ethyl radicals. So if there are more ethyl radicals there, the reaction will speed up. Going back here to our questions. Ester C, which is here, is formed when A is heated with methanoic acid and a few drops of sulfuric acid acting as a catalyst. Name C and draw its structure. Okay, so we can just do this here. We have ethanol is reacted with methanoic acid, which is HCOOH, and the product that we form is, well, we still have our ethyl from the alcohol, and it forms the ester there when you've only got one carbon here, so that's methanoate, and here you've got two carbons, so the product there is called ethyl methanoate. In your drawing, circle the carbonyl group of the ester. Okay, so I've circled that there. That one there is the carbonyl group of the ester. What name is given to the type of reaction that occurs between sodium hydroxide and C? So if you react that with NaOH, what happens is you cleave off the ester and it's a saponification reaction. So it's base hydrolysis or basic hydrolysis, known as saponification. Which is the answer, okay? So what happens there is you lose the alcohol and you form the salt, which is sodium methanoate. And that is that question done.